Let me introduce the presentation on the topic Design of Rapid-Hardening Cementation Repair Mixture for Increasing the Sustainability of Concrete Structure. Sustainability in concrete construction is not just about the material used, but also about the longevity of the structures built. Enhancing the durability of concrete extends the lifespan of structure, reducing the need for repair and rebuild, thereby conserving a resource. Causes of building structure destruction included environment influences, improper design of concrete and mortar. This leads to deformation and cracking, which reduce the durability of structure. Interface between cement-based repair materials and concrete substrate is a problem today. Therefore, the aim of this work is to design composition of rapid hardening, non-shrinking cementation mixture to enhance the sustainability of concrete structure, to study the process of their structure formation and determine their physical and mechanical properties. As a binder of a repair mixture was used Portland limestone cement compositive strength class 42.5 R from Ivano-Frankivsk cement plant. The active mineral aluminum containing additive fly ash from Burштyn TPP was used for research. The specific surface area of fly ash is 4,200 cm² per gram. Sodium tetrahydroxyaluminate was used as an alkaline activator and accelerator of setting. The high aluminum oxide content enables for formation of calcium hydrosilicates and calcium hydroaluminates in the cement mixture. Polycarboxylate ester superplasticizers were used to modify the mixture. Highly effective polycarboxylate superplasticizers with the nano-designed molecular chains polycarboxylate ester was used as a modifier in order to increase strength through significant reduction of water to cement ratio. Fine aggregate sand were used to design the cement mixture with a finest model of 1.25 fine sand from Davidov deposit and fine model 2.76 coarse manufactured sand. To obtain highly effective rapid hardening repair mixture with the most compact mesostructure sand of different fraction were optimized. It was found that replacing quartz sand, finest model 2.76 with 10% fly ash increased bulk density to 1,683 kilograms per meter cubic and reduced porosity to 35.3%. The composition of repair mixture were designed using the method of experimental design based on criteria of setting times and strength. Fly ash from 0 to 20% and complex modifier sodium tetrahydroxyaluminate and PCE from 0 to 5 mass % were used as variable factors. The introduction of 10% fly ash and 5% alkaline modifier allows to accelerate settings time of 70 minutes initial and 140 minutes as final. The optimal composition of additive 10% fly ash and 2.5% alkaline modifier ensures rapid hardening with compressive strength of 9.8 MPa and flexural strength of 3.4 MPa after 14 hours hardening. The standard strength of the optimal composition is 70.9 MPa, while reduced temperature compressive strength reached 54 MPa. It was established that the high technical effect of the repair mixture is achieved after 14 hours is 64%. The optimal composition of non-shrinkage repair mixture can be classified as a rapid hardening mixture. The developed rapidly hardening cement mixture are characterized by shrinkage deformation after 28 days of about 0.06 to 0.25 mm per meter. The adhesion strength to the concrete base after 28 days hardening is 3.2 MPa. X-ray phase analysis and microstructure of modified cement paste were investigated. The addition of 2.5% of combined alkaline additive and fly ash reduced the Portlandite content by 2.7 times, which indicates an intense pozzolanic reaction in the modified cement paste. The developed rapid hardening non-shrinking repair mixture were used for repairing elevator foundation and reinforcement during column foundation restoration. So complex implementation of the effect of the physical optimization and alkaline activation ensures the production of effective rapid hardening non-shrinking cementation mixture for repair of concrete structure in accordance with the requirement of sustainability. Thank you for attention.